Understanding skeletal deformities. A look inside our framework. Our skeletons are incredible. They provide the framework for our bodies, protect our vital organs, and allow us to move, but sometimes things can go wrong. These are called skeletal deformities. Skeletal deformities are irregularities in the shape, size, or alignment of bones. They can be present at birth or develop later in life. Some are mild and barely noticeable, while others can be severe and debilitating. These conditions can impact people of all ages. They can affect mobility, cause pain, and lead to other health complications. Understanding the causes of skeletal deformities is crucial for diagnosis, treatment, and improving the lives of those affected. In the next sections, we'll explore the three main culprits behind these conditions: genetics, hormones, and nutrition. We'll delve into specific examples, understand their impact, and discuss how we can address them. When genes go wrong, inherited skeletal deformities. Our genes are like blueprints that dictate how our bodies develop, including our bones. Sometimes errors in these blueprints can lead to skeletal deformities. These are known as genetic deformities. One example is Achondroplasia, the most common form of dwarfism. This condition affects bone growth, resulting in shorter arms and legs, while the torso remains relatively normal in size. Another example is osteogenesis imperfecta, also known as brittle bone disease. People with this condition have bones that fracture easily, often from minor trauma or even spontaneously. Marfan syndrome is another genetic disorder that affects connective tissues, including those in bones. This condition often results in individuals being tall and slender with long limbs and fingers. They may also experience problems with their heart and blood vessels. Genetic deformities are often present at birth, although some may not become apparent until later in childhood. While there is no cure for these conditions, treatments focus on managing symptoms, improving quality of life, and preventing complications. Hormonal havoc. How hormones impact bone growth. Hormones are chemical messengers that regulate various bodily functions, including bone growth and maintenance. When hormone levels are disrupted, it can have a significant impact on skeletal development, leading to deformities. Growth hormone deficiency, as the name suggests, occurs when the body doesn't produce enough growth hormone. This can lead to short stature in children. On the other hand, an excess of growth hormone can cause gigantism in childhood or acromegaly in adulthood, both characterized by excessive growth. Hyperparathyroidism, a condition where the parathyroid glands produce too much parathyroid hormone, can lead to weakened bones as calcium is leached from them. Conversely, hypothyroidism, characterized by an underactive thyroid gland, can also disrupt bone growth and development in children. Treating hormonal imbalances often involves medication to regulate hormone levels. Early diagnosis and intervention are crucial to prevent or minimize skeletal deformities associated with these conditions. The building blocks of bones, nutrition, and skeletal health. We often hear about the importance of a balanced diet for overall health, but did you know that nutrition plays a vital role in building and maintaining healthy bones? Just like a house needs strong bricks and mortar, our bones require a steady supply of essential nutrients to grow properly and stay strong. These nutrients include calcium, vitamin D, phosphorus, and protein. Calcium, the most abundant mineral in our bodies, acts as the brick, providing strength and structure to our bones. Vitamin D acts as the helper, enabling our bodies to absorb calcium from the food we eat. Phosphorus works alongside calcium, ensuring the mortar holding our bones together is strong and resilient. Protein provides the building blocks for collagen, a crucial protein that provides bones with flexibility and resistance to fractures. When our diet lacks these essential nutrients, it can lead to a range of skeletal deformities. In the following sections, we'll delve into 4 major conditions caused by nutritional deficiencies: rickets, osteoporosis, scurvy, and protein energy malnutrition. Section 5. Rickets, the softening of bones. Rickets is a condition that affects children primarily due to a deficiency of vitamin D. Vitamin D is essential for the body to absorb calcium, which is crucial for building strong bones. When children don't get enough vitamin D, their bones can become soft and weak, leading to deformities. Children with rickets may have bowed legs, delayed growth, and bone pain. In severe cases, the rib cage can be affected, leading to breathing difficulties. Fortunately, rickets is preventable and treatable with vitamin D supplementation and ensuring adequate calcium intake. Section 6. Osteoporosis, brittle bones, and fragile lives. Osteoporosis is a condition that weakens bones, making them fragile and more likely to fracture. It's often referred to as a silent disease because bone loss occurs gradually over time and there may be no symptoms until a fracture occurs. While osteoporosis can affect people of all ages, it's more common in older adults, especially women after menopause. This is because estrogen, a hormone that protects bone health, declines after menopause. A balanced diet, rich in calcium and vitamin D, regular weight-bearing exercise, and avoiding smoking and excessive alcohol consumption can help prevent osteoporosis. Treatment often involves medications to slow bone loss and reduce the risk of fractures. Section 7. Scurvy. The scourge of sailors and the importance of vitamin C. Scurvy, once a dreaded disease among sailors on long voyages, highlights the importance of vitamin C for skeletal health. Vitamin C is crucial for collagen production, a protein that provides bones with flexibility and strength. A lack of vitamin C can lead to weak bones, delayed wound healing, and gum disease. In severe cases, it can even be fatal. Thankfully, scurvy is easily preventable and treatable with vitamin C supplementation, readily available in citrus fruits, berries, and leafy green vegetables. Section 8. Protein energy malnutrition, a global threat to bone health. Protein energy malnutrition, or PM, is a severe form of malnutrition resulting from inadequate intake of protein, energy, and other essential nutrients. It's a global health concern, particularly affecting young children in developing countries. PM can have devastating consequences for skeletal health. It can lead to stunted growth, weak bones, and an increased risk of fractures. Addressing PM requires a multi-pronged approach, including improving food security, providing access to nutritious food, and addressing underlying poverty and social inequalities. Section 9. Early detection and treatment, key to managing skeletal deformities. Early detection and treatment are paramount in managing skeletal deformities. The earlier a condition is diagnosed, the sooner interventions can be implemented to prevent or minimize long-term complications. Regular checkups, especially during childhood and adolescence, are crucial for monitoring growth and development. Parents and caregivers should be aware of any unusual skeletal changes or symptoms such as bone pain, delayed walking, or frequent fractures. Treatment for skeletal deformities varies depending on the underlying cause and the severity of the condition. It may involve a combination of approaches, including medications to regulate hormone levels, increase bone density, or manage pain. Physical therapy to improve muscle strength, flexibility, and range of motion. Braces or orthotics to support and correct bone alignment. And in severe cases, surgery may be necessary to correct deformities, stabilize bones, or replace joints. Section 10. The future of skeletal health research and advancements. The field of skeletal health is constantly evolving, with ongoing research leading to new discoveries and treatment options. Scientists are working to better understand the complex interplay of genes, hormones, nutrition, and environmental factors that contribute to skeletal deformities. Gene therapy holds promise for treating genetic disorders, potentially correcting the faulty genes responsible for certain conditions. Advances in regenerative medicine are exploring ways to stimulate bone regeneration and repair, offering hope for those with severe skeletal deformities. Furthermore, there's a growing emphasis on personalized medicine, tailoring treatments to an individual's unique genetic makeup and lifestyle factors. This approach aims to optimize treatment outcomes and minimize potential side effects. Section 11, Conclusion, Building Strong Foundations for Life. Our skeletons are marvels of engineering, providing structure, protection, and mobility. However, genetic disorders can disrupt this intricate frame. Skeletal deformities. Understanding the causes, symptoms, and treatment options for these conditions is crucial for improving the lives of those affected. Early detection and intervention are long-term complications. By prioritizing bone health through a balanced diet, regular exercise, and seeking timely medical care, we can build strong foundations for ourselves and future generations. Through continued research and advancements in medicine, we can strive to alleviate the burden of skeletal deformities and lives.